All right, in this video, we're going to talk about Lewis structures and their ion structures. And so often on the New York State Regents exam, you'll see a question that may say, draw the Lewis structure for example, some ion. Instead of the normal atom, we're going to use the ion. So what we have to remember is what happens with ions. And we have to remember that metals lose electrons and become positive ions, where nonmetals gain electrons and become negative ions. And one of the ones that they often choose the most are the negative ions, or the nonmetals, the halogens specifically. And for example, if you look up fluorine is 2-7. So normally the Lewis structure of fluorine would look like that, 7. Remember, only using this outer number, which is known as the valence electron number. And so we're usually only doing that. But fluorine also has a -1 in the corner. That number at the top right is listed as the oxidation number on your reference tables, and that is basically regarding how many electrons will be lost or gained when they typically form a bond. And fluorine will typically take electrons. It's the highest electronegative value. The whole table S chart for electronegativity is based on fluorine. So when fluorine takes an electron, this would be the atom Lewis structure, but the ion Lewis structure of fluorine would be looking like this. It would have a -1 in it because it has an extra electron. Now, whether you drew the extra electron as a dot, or if you wanted to represent that it came from another atom and used a different symbol, maybe an X or a square, triangle, something, that would be okay. I would accept it because I'm understanding what you're representing, and that's usually how I represent it as well to my students, to show that it actually came from something else. So again, big difference there. If you had something that was in the previous group, so instead of group 17, let's say you had group 16, something like, oxygen or sulfur, oxygen's number is 2-6, and it has a -2 in the top. So oxygen normally might look like that. It has its 6 electrons, and it obviously needs 2 more. So the atom, the Lewis structure of the atom would have our 6 dots. If we were to do the ion, you could have something like this with the original 6, and then maybe there's 2 more. So I'll use X's, and it would be a -2. So the ions are going to represent those additional electrons that have been gained, which again is a definition of an ion. An ion is a charged atom or a charged molecule or particle, not necessarily a molecule, but a particle. So table E, for example, has the polyatomic ions. And you're going to be able to see how many extra electrons they've either lost or gained. And like I said, typically you would see that they've gained electrons. Not to say they couldn't do ones with loss. So for example, if we go over to the metal side, sodium is 281. Sodium normally is 1 electron with the atom. The ion, let's put the ion up there, but the sodium ion you may see in brackets. No electrons, now has a +1 charge. So hopefully you found some value here in looking at the Lewis structure of ions, because again, sometimes those do show up on the Regents exam in New York State. Thanks.